So now that we've gone over a little bit of a primer on airspace and why it matters and what air traffic control is, let's have a quick look at the Fresnel zone and how radio transmissions actually work, because this is really important. If our drone loses control or video signal, that can be an out of control situation. So there's some basic concepts here, just like in airspace, that if you as a drone operator understand it, it's going to make a really big difference in the performance that you have, how you work, and also the decisions that you make. And it's very, very important stuff. So let's jump right into Fresnel zone theory. So the first really important thing with antenna theory and radio transmission theory is that antennas work in either a sort of like a balloon way, so it's transmitting all around in an equal distance, or in a projected way, okay? So it's the same with microphones, but there's an Omni Pattern, which is going to be everything all around equally, right? Just like this, right? Equal, blah, blah, blah. And then we have a directional pattern. So let's see, this is what it looks like here. This is going to be our Omni pattern, and this is going to be our directional pattern. So with all things in physics and radio, it's not exactly perfect the way things work. There's these interesting anomalies, right? So even in a directional pattern, there's also behind the transmitter, it's highly sensitive as well. And there's all these other patterns, and this depends on the actual type of antenna and can vary. But as far as understanding these two types of antennas, it's very important. So in an operation, if one is going to be flying in a circular pattern like this, then an Omni antenna system is going to be much more effective. And then on the other hand, if somebody's doing a relatively long distance path, flight path, we're going to want to look at directional antennas. So this is all really important stuff. Choosing antennas is going to become more and more important for ground stations and advanced commercial operations. Understanding how these patterns work is critical. Let's move on. Here we have another nice diagram showing how the patterns actually work. So in this example, when we have two antennas that are elevated, there's not really too much of an issue because the signals aren't bouncing off the ground. But an important concept to understand and this is the Fresnel zone, is that it can actually be calculated how things bounce, but what will happen is the signal will hit the ground and bounce back up. And that's what we call multipathing. So when we have analog race band FPV racing and you see all those old TV analog lines, generally the TV analog lines is multipath interference, which is the signal bouncing from the ground and hitting the receiver antenna at a slightly different time, out of phase from the original direct signal. Okay, so it's important to understand that in an interior situation where you're filming, or you're in whatever RF or radio frequency situation on the interior, these signals are bouncing everywhere and coming back to your antenna at different times. That creates confusion for the signal and will result in artifacting of some sort of or another. On analog systems, it will be different line patterns that are coming through, the scrolling line sort of interference that we're used to. And on digital systems, it'll be blocked systems like this or just straight delays. So that's an interesting concept. The reason why FPV racing still uses analog systems is because there's no latency. They're very low latency. So the signal is going analog, connects to the receiver, and the interference is very real time. Whereas in digital systems, when it's going through a 5.8 signal or a 2.4 gigahertz signal, it's going to be definitely a delay because there's a lot of processing going on into the analog digital analog path. And then it's going to just blank out and freeze.